Hi GOR, this is Unit 3B, Lesson 3, Properties of Parallelograms. So the rest of this unit is just going to be about parallelograms and their properties. So we're going to start with the parallelogram itself, and then we move on to rectangles, squares, and rhombuses. So a parallelogram is a quadrilateral. So a quadrilateral has four sides. So it's quadrilateral with both opposite sides parallel. It's a quadrilateral with both opposite sides parallel to each other. And I know you know what this looks like. I'm going to draw one so we have it. Now if I want to call it parallelogram A, B, C, D, you can start the A wherever you want, and then you can just go in order. You can go clockwise or counterclockwise. So I have parallelogram A, B, C, D. To show the top is parallel to the bottom, it's like a greater than sign. That little symbol means parallel. And then to show that the left is parallel to the right, I can do two of those little greater than signs. But a parallelogram is a quadrilateral with both opposite sides parallel. So there are 5 properties that we're going to list as being true about parallelograms. See if you can figure them out with me as we go along. The first one is just the definition. Both opposite sides are parallel. There's basically 2 properties about the sides and 2 properties about the angles, and then 1 property about the diagonal. So besides being parallel, what looks to be true about the top and the bottom and the left and the right? If you were to take out a ruler and measure them, you would find that they're both equal to each other. So both opposite sides are congruent. They're the same length. The top is equal to the bottom, and the left side is equal to the right side. Now we're going to do 2 things about the angles. So opposite angles are angles that are opposite each other, like angle A and angle C are opposite angles, all right? And angle B and angle D are opposite angles. If you were to take out a protractor and measure those angles, you would find that the opposite angles are congruent. So opposite angles are congruent, meaning they're the same. Angle A is congruent to angle C, and angle B is congruent to angle D. And I highlighted them for you so you can see which ones I'm talking about as well. So the opposite angles are congruent. The angles that are next to each other, like A and D, or even A and B, we call those consecutive angles. So they're next to each other, one right after the other. The consecutive angles are not congruent. They don't look congruent. They are actually supplementary. And supplementary means they equal 180 degrees. So the consecutive angles are supplementary. Angle A plus angle D is 180. Angle C plus angle D is 180. And that makes perfect sense because the 4 angles of a quadrilateral add up to 360 degrees. And then the last thing has to do with the diagonals. So the diagonals bisect each other. Doesn't mean they're the same length. It means they cut each other in half. The diagonals bisect each other. So if I was to draw these diagonals in, they obviously don't look the same length. AC is much longer than BD, but they cut each other in half. So the halves are, the 2 halves are equal to each other. All right, so just a few problems, and then we're actually going to do a proof together just to show you why some of these properties are true. But if I'm looking at exercise 1 right here, remember the opposite sides are congruent. So the first question wants to find AD, which is the left side. Well, it equals whatever the right side is. So BC was 8, therefore AD is 8. DC is right here. That's the bottom side. Again, opposite sides are congruent. If the top is 15, then DC is 15. Now for the angles, angle A is right here. It's next to angle D. Angles that are next to each other are supplementary. So I'm going to do 180 minus 68 is 112. Angle B is 68 because opposite angles are congruent. Angle B and angle D are congruent to each other. Also, A and B are supplementary. They add up to 180. And then let me write that in. Angle B is 68. And then angle C is whatever angle A is because opposite angles are congruent, or it's supplementary with angle B. 2 is just another one. So some more practice. Remember, the opposite sides are congruent. So JK is 21 because ML was 21. All right. And then I want to find KL, which is the right side. Well, it equals 29 because the left side was 29. And then remember, opposite angles are congruent to each other. So angle J is 127 because angle L is 127. And then angle K and angle M are each going to be 53 because these have to be supplementary. 180 minus 127 is 53. So not too bad. It gets a little bit trickier when we have algebra that we have to do, but this is just the basic rules right here. And the last one, I have the same idea, except I did add in my diagonal, so it'll be a little bit different. UT is going to be 27 because RS was 27. And then ST is going to be 18 because RU is 18. And I told you that RT was 30, so let me highlight that. RT is this whole line right there. RT is 30, because they told me that right here. Remember, the diagonals cut each other in half, so that makes each half 15. So RV is 15, and VT is 15. Okay, and they told me, let me grab another color. I almost didn't see this one. They told me that VU, this little part right here, is 7, and that makes VS also 7. Okay, and then we have our proof on the back. So we're going to prove the following sentence. If a quadrilateral is a parallelogram, then its opposite sides and angles are equal in measure. All right, so basically, the if is my given. The if is my given. ABCD is a parallelogram. The then is what I'm trying to prove. I'm trying to prove the opposite sides, A, B, and C, D are congruent, and I'm trying to prove opposite angles, angle A and angle C are congruent. All right, so ABCD is a parallelogram. We're just filling out the reasons for this. That's the given. How do I know that AB is parallel to DC and BC is parallel to AD? Well, that's basically what a parallelogram is. Remember our definition. Both opposite sides are parallel. So we're just going to write definition parallelogram. Now, if those opposite sides are parallel, that makes angle 1 congruent to angle 2 and angle 3 congruent to angle 4, because those are alternate interior angles. And when I have parallel lines, the alternate interior angles are congruent. I'm trying to prove these triangles, even though I'm talking about a parallelogram here. See how that diagonal BD cuts that parallelogram in half, and I now have two triangles? Why is BD congruent to BD? Because they share that side. Anything is congruent to itself with the reflexive property. I've been marking my triangles all along, everything that's congruent. So the triangles are now congruent by angle, side, angle. Okay, and if you can't see that, I'll do that in a little bit thicker pen. This is an angle right here. This is a side, and this is another angle. So I got angle, side, angle. Oops, get a smaller pen again. So once I know that the triangles are congruent, all of the corresponding parts and sides are congruent to each other. So AB is congruent to DC. Those are opposite sides. And angle A is congruent to angle C by CP, CTC. So the triangles are congruent, and once the triangles are congruent, all of the corresponding parts are congruent, and the opposite sides are corresponding parts, and the opposite angles are corresponding parts. So I basically just proved that the opposite sides and angles in a parallelogram are equal. I did it.